Welcome to the second part of the relational databases in health IT. And this particular lecture has to do with how a database functions within an electronic medical record and the use of SQL to pull reports from those electronic medical records or electronic health records. The objectives of this lecture are to understand a relational database and how it can be applied to health data, learn how to write an SQL report for processing on a single table, and learn how to write an SQL report for processing on multiple table databases that contain joins. So from the reading, you know that a relational database, this is the blueprints when we build an ER diagram. It's how we're going to set that database up. It denotes our primary and foreign keys. It has a standard record format, and that standardization is important so that users can find data in any type of database. Relational databases and queries contain appropriate names of fields, what tables those fields are in, and how they're connected or joined. What is the relationship between the different tables in a database? The standard record format that you read about in Chapter 2 of Cronky talks about this standardization. I'm going to skip ahead here to the SQL language or structured query language, sometimes pronounced SQL, sometimes pronounced SQL, was originated by IBM in the 70s, around the same time that databases began to be designed. And the standardized SQL language came about in 1992. And all EMR vendors use some form, for the most part, of a SQL type of query or SQL statements. You may hear that. And if you can master SQL or understand SQL, you can write a report in almost any other database query language. They all use similar conditional formatting. They all use structured language of some sort, where-from statements, if-then statements that can be used. And for example, at the hospital, we have Cerner. Cerner has a proprietary form of SQL that is called CCL because it has to do with Cerner something language, Cerner content language or something. But again, it still uses the same structure. It's sort of like learning any of the Romance languages. If you learn French, you can usually understand parts of Spanish and Italian because they're all based on the same Latin-based language. So SQL is the basis for all database querying. So the entity relationship diagram, or the ER diagram, this is an example of what you might see in an electronic medical record, where you have a patient identifier, you have something that you're looking for related to that patient. So that patient's going to have lab work, they're going to have maybe x-ray reports, they're going to have registration information or insurance information, immunization information or vaccine information. And so in this example, you see we've got our patient information, we've got vaccine information, we've got lab information, and we've got a healthcare facility. So with this information, you should be able to write a report that says something like, show me all patients who had a vaccine at this particular facility, or show me all patients that had a positive influenza and an influenza vaccine, and show me what facilities they received that vaccine at. So using these diagrams can help you with your report writing and show you the relationship between all of these tables. And you'll notice that in these diagrams that are standardized, and this is from an Access database, the primary key is denoted by the little key symbol, and then you've got your join, which is the black line, this black line between them that goes to the foreign key. In a perfect world, it would look like this. Your lab ID would be your link to your lab ID. Your vaccine ID would be your link to your vaccine ID. But this is not reality. And even in Cerner being all one big system, it's actually had many people configuring it, or a lot of times these are hybrided or a conglomerate. So it was 2 or 3 systems that one big company bought and fit together. And so the databases aren't always built this smooth. In addition, you may have foreign systems that are integrated or interfaced with your main hospital information system. So, for instance, we have a cardiovascular information system called McKesson, but we have Cerner as our hospital information system or our clinical information system. And those 2 databases are very different. The table that contains the patient name, first name, last name, social security number, medical record number in Cerner is going to have different fields to map to in McKesson. So your L name, in this example, your L name in Cerner might be last name spelled out in McKesson. And you're going to have to be able to map those 2 in order to pull the information that you need. And it can get pretty ugly and messy if you don't have a clear diagram, which this shows you, of how it's linked. If anybody's ever used Crystal reports before, they have a GUI that does exactly this for you. You pull your tables together and it joins. A lot of them have automatic joining, and it will do the best to guess for you. But again, if you're pulling from foreign systems, you're going to have to tell it what links you want to make and understand what the data dictionary from that vendor is telling you. And any vendor should have a data dictionary that they can provide to you to help with some of that mapping. So the relationship model provides an efficient method for storing data. When we talk about databases and normalizing databases, it allows massive amounts of information to be stored and then easily looked up because you're only pulling pieces of data from different areas in order to display lots of data or complete data. SQL is also known, or SQL is also known as a data manipulation language, which is, again, providing that standard for report writing, and it uses what's known as a select statement. So the select statement is, whenever you're writing reports, you need to think about what it is that you're looking for. What are you trying to find? You're trying to find all patients with the last name Smith. So if you go in, we're going to start right at the beginning with a registration conversation. You come into the emergency department and you need to be seen. The first thing they're going to ask you is, what's your name? What's your social security number? They're inputting this information into a search engine to see if you have ever been there before or at any time in the facility, so they don't create a duplicate medical record number. They want to use the same person that exists in the database. We don't want to create another row in the database with the same information. We want to use the existing row in the database, which is you, and expand upon that. So then we want to know, when you're doing your report writing, then show me all of this, or select all of these people. We want to be able to sort them. Maybe it's alphabetically, maybe it's chronologically, and maybe we need to narrow it. We want to show all the people with last name Smith, but only if they're greater than 75 years old. Or we want to show all of the people with a last name Smith, but only if they're over 75 years old and female, because you're trying to narrow it down so it doesn't pull back as much data. So here's an example of your select statement. And this is a very standard select statement, the very first line. This employee is the table. Your E&O, or employee number, is the primary key. That's why it's underlined. Then you have your last name field, your first name field, and the phone number field. So you've got 4 fields with the ENO being your primary. Our statement, our select query, our select statement is saying select the employee number, the first name, the last name fields, so 3 fields. Select these 3 fields from the table called employee. Now we're going to expand upon it and say where. Not only do we want to select or display the employee number, the first name, and the last name, which resides in this table, the employee table, but we want only individuals that have a last name of Johnson. And then we're going to order them by first name. So we know everybody's last name is going to be Johnson. So we want the sort to be alphabetically by first name. So Alan Johnson, Michael Johnson, Penelope Johnson, and Stephen Johnson. And we want them in that order. So each one of these pieces make up this complete statement or complete sentence. And here's a couple of websites that are used by Tom Gallagher that will take you out. And in this example, this is the one we're going to go to first. We're going to look at the banner. And everybody refers to this as banner. Grades are out on banner. Student information can be out on the banner. This is just one big set of SQL statements in the background, and each one of these drop downs is your filter. So you are creating a select statement. You're clicking on the subject and showing, saying, show me all the subjects, and for this certain number of credits, and you could select that only meet on these days of the week. That is a select statement. Show me all courses with this many credits that only meet on these days of the week. That's just a simple SQL select statement that's in the background. Banner uses an Oracle database, but it's still using the same kind of structured language. The where clause has comparison operators, and you can use comparison operators to further sort or narrow the search down that you're looking for. And the most common ones, obviously, we've got equals. Not equals is the greater than and less than facing each other. We've got greater than and less than, greater than or equal to, or less than and equal to. Whenever we're looking for those comparisons, the syntax is names, texts. So in this example, first name equals Jane, and it's in quotes. Anytime you have text, it's going to be in quotes when you're looking for that value. Think of even on the internet. There was a time, I'm not sure if it still is popular, but if you had several characters like sardines in a can, you could put that in quotes in the internet search engine so that only if that exact combination of words in that exact order appeared, it would find and return only those that had that exact match. And that can help narrow your search. Same thing here, put it in quotes. Numeric values are never in quotes. The asterisk is used to show all fields, so it's a type of wild card. So when we have select asterisk from employee, we're saying select all the fields from the table called employee. Percent and like are used for text. So if we were trying to say select, in this statement, we're saying select all fields from the table called employee where the last name begins with the letter J. So it's like J, and the percent sign means and anything that comes after the letter J. We just want it to begin with J. Join is how you connect or display fields across multiple tables. So we've got our primary key and our foreign key. Those two are related in some form to each other. They're linked to each other. And that's what allows us to pull data from multiple tables. So let's see if we can go back. Go Go to slide. So in this example, right, our EMR ID, so patient EMR ID is linked to EMR ID, and we're using both the table name and the foreign key name in here. And in this case, if you notice, remember what I talked about the key? So this is actually primary, that's why it's got the number 1. So going, whoops. So going this direction, EMR ID is the primary key in the EMR table, but it is the foreign key in the patient EMR table. And so if I want to get from this table to this table, I'm going to link the EMRD with the EMR ID, but then that allows me to go, say, from this table to this table because the patient's IDs are mapped. So do you see how that kind of works? And that's what we're talking about here, the foreign key to primary key relationship. So here's some examples, and this is out on that other link that was provided. You can go out here and play and practice some of these SQL statements. So in this example, we've got these two tables, the director table and the movie table, and they're linked by the director ID. That is their primary to foreign key in this particular relationship. And this statement saying, if you recall, right, we've got the asterisk, so select all fields from the movie table. And so we've got the movie ID, see the movie ID? We've got the director ID, title, and release year. So all 4 of those fields are being displayed and the entire database is being displayed. There's your join. So now we're going to add in our where statement. So select from movie where release year was greater than 1991. There's our select statement. And what did it return? Only the movies in the database that had a release year greater than 1991. Another one, select all fields from the movie table where the title is like S. So where the title begins with the letter S. We had 2 returned. Select all fields from the director table where the last name equals S. And I have an extra director in there, and it still worked, which is pretty amazing. And there you can see our last names were returned, and we had 3 movies. Another example, all fields from director where the birth year is less than 1950. And again, I apologize, I left the extra director in there, but it still worked. And there's your birth years less than 1950. So what if we wanted to say a couple different things? Not only do we want to see where the birth year was less than 50, but we also want to see where the last name begins with K. So only show me, so look at all the fields from the director table and only show me directors with that birth year less than 50 and the last name that begins with K. And there we have it. The dot operator can be used to denote that join between the different tables. So you've got employee table and the field is last name, it's employee.lname, or the field was lname, I should say. So you want to select employee.lname from employee. Now in this example, we're going to show this is the director table, this is the movie table, this is the director ID, and the director ID. In the director table, it's director ID. In the movie table, it's movie.director ID. So it's the table name first, and then the field name. And you can see where that join's happening. So again, director director ID. That's director ID. Movie, and it's joined to movie.director ID. Movie to director ID. So here's an example of this kind of statement. We're going to say, select the last name, the title, and the release year. So we went 3 different fields from 2 different tables, right? We have last name over here, but the title is over here, and the release year is over here too. So we've got the last name from the director table and the movies from the movie table, the titles and the release year. Select these 3 fields from these 2 tables. And you've got to separate these by a comma and a space. It's very specific this way. So select these 3 fields from these 2 tables, and the condition is where the director ID equals the movie ID. So that's what's joining those 2 together. And this is what it returned. All the last names, titles, and release years from 2 different tables and put them together. And this is just kind of up close, so it was a little easier to see. Director ID, there you go. Having a little fun with PowerPoint. So again, you can go out to these couple of websites and play with some SQL statements. I did not give you an assignment because of spring break coming up to actually go out and play with the SQL statements, but I hope that you'll go out. There's also some other links, SQL Zoo or something like that, on the lesson page that you can go out and play around with SQL. Again, if you can understand that logic, there isn't anything that you wouldn't be able to do. There are always jobs for report writing, and they always follow some sort of standard query language formatting that if you understand SQL, you can pretty much grasp any other data manipulation language that is out there. And it's one of those jobs you can also do from home as long as you're provided some sort of VPN access or other means to access the database of the vendor or the entity that you might be contracted with. If I could do it, that would be the job that I would look for. Okay, have a good spring break. There'll be a short lecture on Friday going over project management and strategic planning, but I'll promise to keep it short. Thanks.